Hello dear students, welcome to Corner classes. In this session we are going to discuss linear differential equations. Okay, let us first understand what is a linear differential equations. A equation of the type that dy dx plus p into y is equal to q, where p and q are either constant or functions of x. Okay, where p, q are constants or functions of x. Let me give you an example. If we consider a equation something like this, dy dx plus y is equal to sin x. This is a linear differential equation. How? Because if nothing is there as a coefficient of y, means this is 1, which is a constant like p, and sin x is a function of x like q. So that means what we can say, dear students, this 1 is as if like p, okay, and this sin x is as if like q. Correct? In the similar manner, we can have a differential equation something like this, that dx dy plus p1 into x is equal to q1. That is also a linear differential equation if p1, q1 are either constant or functions of y. Okay, so what we can write, where p1, q1 are constants or functions of y. Okay, let me give an example. Suppose if we take an example something like, let me take it from my notebook. An example something like this, dx dy plus x is equal to cos y. Now if you look at it, so whatever is coefficient of x is nothing is there, that means we can assume it 1, and this 1 is actually as if p1, that is a constant. Correct? And this cos y is a function of y as if it is q1. So dear students, if we get a differential equation something like this, that dy dx plus py equal to q, where pq are constants or functions of x, or dx dy plus p1x equal to q1, where p1 q1 are constants or function of y, then we can say it is a linear differential equation. Okay, let me give you couple of more examples of linear differential equations. So let me take it from my notebook and give it to you the example. Okay, suppose in this category dy dx we can have a differential equation something like this, dy dx plus 1 by x into y is equal to e power x. Okay, if you look at it, or let me write down the other one, or you can write dy dx plus 1 by x log x into y is equal to 1 by x. Okay, so let's look at it. If you look at this one, the dy dx plus 1 by x into y equal to e power x, this 1 by x as if p as a function of x, and this e power x is as if q function of x. If we take dy dx plus 1 by x log x into y equal to 1 by x, this 1 by x log x is as if p function of x, and this 1 by x is as if q function of x. Correct? In the similar manner, in this category, we can write differential equations something like this. Okay? That dx dy minus 2x by y is equal to y square e to the power minus y. Okay? So, in this case, what we can see, dear students, that minus 2 by y as if this is p1 function of y, and y square into e power minus y as if q1 function of y. Correct? We have seen enough examples and in both the categories. Now, how to solve a linear differential equation, most important part that we are going to discuss now. Okay? So, dear students, so let us first concentrate on this one. Okay? That we have a linear differential equation something like this, dy dx plus py equal to q, and we are going to see how to solve this type of differential equations. To solve this type of differential equations, we need to introduce a term called integrating factor. Okay? It is known as integrating factor. Integrating factor. Okay? And in simple terms, it is written as IF. And what is this integrating factor, dear students? This is equal to e power integration, whatever that p, that function of x, it is e to the power p dx. That is what is known as the integrating factor. Correct? Now, what is the purpose of this integrating factor? This integrating factor will be multiplied to the both sides of the given linear differential equation. That means what, dear students? From this equation, if we multiply both sides of this equation by this integrating factor, that is e power integration p dx, let's see how it looks like. It will be something like this, e to the power integration p dx into dy dx plus e power integration p dx into p into y is equal to q into e power integration p dx. Correct? You may wonder that why this has been multiplied, what we are going to achieve. And here's the most important point. If you look into this left hand side, that is e power integration p dx into dy dx plus e power integration p dx into py, it actually gives us something very meaningful. If you look at whatever I have marked into the green box, this is nothing but ddx of y into e power integration p dx. Let me explain you why it is so. And right hand side, it is as it is q into e power integration p dx. Okay? Now, left hand side, why it is so? Let us consider this thing, ddx y into e power integration p dx. Then it is a product rule. First one is y, okay? First function is y, second function you can take e to the power integration p dx. So, what it will be? It is u into v rule. It means y into ddx of e power integration p dx. That means e power integration p dx into ddx of integration p dx. That is nothing but p. Let me write it down, okay? In a different color. So, what I am saying is that, let me write in the red color. Okay. What I am saying is that if we take that ddx of integration, ddx of y into e power integration p dx, that means y into ddx of e power integration p dx plus e power integration p dx into d dx of y, that means dy dx. If you look into the second term, that is already there, this one. This one is already this one, correct? This first term here. And if we just concentrate on this one, so this is equal to what? Y as it is. And d dx of e power integration p dx. E power anything is differentiation is same thing. That means it is e to the power integration p dx. Into, by means of chain rule, we can say d dx of integration p dx. d dx of integration p dx. Integration is the inverse process of differentiation. So d dx of integration p dx will give us p only, right? So that means what we are going to get out of here? We are going to get y into e power integration p dx into p, which is nothing but this term, correct? Y into e power integration p dx into p, correct? So that is the most important thing we have achieved. After that, what, dear students? It is simple. After that, what we are going to do? After that, we are going to write, this implies d of y into e power integration p dx is equal to q into e power integration p dx dx. After that, what? Integrate both the sides. Okay. Now this integration will be nothing but integration of differentiation, that will give you y into e power integration p dx. Na? So this will give you y into e power integration p dx is equal to, here, q into e power integration p dx dx, correct? You can just, for the sake of clarity, you can write like this. Now this is the desired integration, and if you solve this one, you will get the solution to the differential equation. Now what is the most important part? If you have a differential equation something like this, its solution is as if that multiply y with the integrating factor is equal to q into that integrating factor dx. Integration of q into integrating factor dx. That means what, dear students? In simple term, what we can say is that the solution to this differential equation, that is dy dx plus py equal to q, is something like this. I just showed you the derivation, but it is simply, its solution is something like this. What is that? Y into multiply that integrating factor. What is that integrating factor? E power integration p dx. And that should be equal to integration q into multiply that integrating factor, okay, and dx. That's it. Now depending on the value of q, we need to solve this one. We will see one example, correct? In the similar manner, if you have a equation something like this, that is dx dy plus p1x is equal to q1, where p1 and q1 are either constant or function of y only. How to solve this one? For that, what you are going to do? Here it will be x into the integrating factor, okay, is equal to integration q1 into integrating factor dy. Okay, what is the integrating factor here, by the way? In this case, the integrating factor is e power integration p1 dy, correct? These are the simple states. So let me summarize before we start solving couple of questions. The first one is that if we have a differential equation something like this, dy dx plus py equal to q, where pq are either constants or function of x only, then the way to solve is that first find the integrating factor, that is e power integration p dx. Then the solution to this differential equation will be y into multiply that integrating factor equal to then integration of q into that integrating factor dx. Depending on the function q, you integrate it and you will get the solution. Similar manner, if it is given that dx dy plus p1x equal to q1, where p1, q1 are either constant or function of y only, then integrating factor is what? E power integration p1 dy. Then what is the solution to the given differential equation? X into multiply that integrating factor equal to integration q1, which is a function of y or constant, multiply with the integrating factor dy. Integrate it, you will get the solution. Let's now go to solve one problem straight away, so that you will understand exactly how this is done. So, how to solve this one in this space? You write it down here. Let me take that example from here, okay? I'm just thinking where to solve it. So let me write it down here. Okay, find the general solution of the differential equation. Find the general solution of the differential equation. What is the differential equation? Dy dx minus y is equal to cos x. First, by looking into the differential equation, we need to understand whether it is a linear differential equation or not. We see dy dx minus 1 into y, so minus 1 is a constant which can be, just like p, which you can assume just like p, and then cos x is a function of x, so it satisfies the condition of a linear differential equation, so it is a linear differential equation. So what is the integrating factor? So let me write it down very clearly here. So nothing is there, that means we can assume it is 1, which is as if like p, and this cos x is as if like q. Then what is the integrating factor? Integrating factor here is that for this question the integrating factor is e power integration p dx, that means minus 1 into dx, correct? So that means what? That is equal to e power minus integration dx, correct? So what it will be? It is equal to e power minus x, because integration dx is x, na? So e power minus x. So what will be solution to our differential equation, given differential equation? So that is driven by here, driven from there, okay? So y into that integrating factor, that is e power minus x, correct, is equal to q into, what is q? Cos x, that is integration cos x into e power minus x dx, cos x into e power minus x dx, correct? Now all we need to do is that to perform the integration of this one, this right hand side. So this is the solution to the given linear differential equation, which is this one, dy dx minus y is equal to cos x. Now let's look into it, how to solve this integration e power minus x cos x dx, okay? Let I equal to integration e power minus x cos x dx, and if you recall, dear students, this is integration by parts. So which one will be the first function? The first function, if you apply the Euler rule, okay, that cos x will be the first function, correct? Euler, a trigonometric function is coming before the exponential function, okay. So, and if you want to know details about the integration by parts, you can look into my video lecture on integrations, okay. It is already available in YouTube. So this is equal to what, dear students? So this is equal to, the first function is cos x into integration e power minus x dx minus integration ddx of cos x, correct, into integration e power minus x dx, and entire thing dx, correct? That is integration by parts. Now what is integration e power minus x dx? It is minus e power minus x. That is equal to minus e power minus x into cos x minus, what is the ddx of cos x? Is minus sin x. So what we can write here, dear students? So here we write minus sin x into integration e power minus x dx is minus e power minus x. So minus e power minus x. So entire thing dx. Okay, now let's do some simplification here. Minus and minus become plus, and that plus is minus with minus. So in simply we can write this is equal to e power minus x sin x dx, correct? So you can write here is that e power minus x sin x dx, e power minus x sin x dx, correct? Now we need to integrate this one using the same integration by parts, by considering sin x as the first function and e power minus x as the second function. So what it will be? So this is equal to minus e power minus x into cos x minus, okay. So what we are going to write, dear students, here? First function is sin x. So sin x into integration e power minus x dx, correct? Then minus integration ddx of sin x, into integration e power minus x dx, and this entire integration, that is integration by parts, correct? So this is equal to what, dear students? This is equal to minus e power minus x cos x minus, now sin x into integration e power minus x dx is minus e power minus x. So what we can write? Minus e power minus x into sin x into, sorry, not into, minus ddx of sin x is cos x, and so let's write integration, that is cos x, into integration e power minus x dx is minus e power minus x. So minus e power minus x entire dx. Now let us simplify. Then what we get? Minus and this minus become what? Plus. So what we can write? Here you can write plus e power minus x cos x dx, plus e power minus x cos x dx, e power minus x cos x dx, correct? So we can give this bracket here, correct? So what we get, dear students? This minus and this minus become plus. So e power minus x sin x. So we get e power minus x. I am writing it. So first we write minus e power minus x cos x plus e power minus x sin x. Okay, and this minus and plus become minus. Minus, what is this? E power minus x cos x dx, that is nothing but I. So we get I. So what we get, dear students? I is equal to minus e power minus x cos x plus e power minus x sin x minus I. That means what we can write is that 2I equal to, okay, so I can write it here. So I am just erasing these intermediate steps. I hope you already got it. Okay, so what we get is that if you look into this, yeah, so both are same. So that implies what? If we bring it here, this minus I, take it into the left hand side, become plus I. So I plus I become, this implies 2I is equal to e power minus x into sin x minus cos x. That implies I equal to e power minus x divided by 2 into sin x minus cos x. Now, whatever we have done this indefinite integration, always there will be a integrating constant. I have not written those integrating constant earlier because it will be finally we can write it. That's why I didn't write it. So what we get, dear students, this value of this integration like this. So what is the solution to the given differential equation? So if I write into the red color, so the solution to the given differential equation become y into e power minus x is equal to e power minus x divided by 2 into sin x minus cos x and plus one integrating constant c. Okay, we can further simplify. This will be equal to, that implies y is equal to sin x minus cos x divided by 2 plus c into e power x. Means in the previous step, if we multiply both sides by e power x, we get this one. So this is the solution to the given linear differential equation. I hope you got a very clear idea about how to solve this thing, right, dear students? Okay, so now let's proceed to the next question. Okay, and in the next question we will see a linear differential equation, something like this. Okay, how it will be? So let me show you. So let me remove this portion. Okay, let me remove. Dear students, as I always say, you also do along with me. Then you'll see that if any doubt is there, you can always ask me. We have our online test platform. There is a feature in which you can you can always contact us. So, and we can proceed after that. So now the next question, what we are going to do, it is based on this one. Okay, so let me write down the question first. Okay, the question is that find the general solution of the differential equation. Find the general solution of the differential equation. What is the equation? Y dx minus x plus 2y square dy is equal to 0. Okay, let's see. So dear students, the equation is that y dx minus x plus 2y square dy is equal to 0. That means what we can write, dear students? That implies we can write y dx is equal to x plus 2y square into dy. Correct? So now let's divide both sides by y and dy. That implies what? What we are going to get? Dx by dx dy is equal to x by y plus 2y square by y means 2y. Since y is not equal to 0 and dy is also not equal to 0, that is why we are able to divide. Okay, now let's see. So this implies dx dy minus 1 by y into x is equal to 2y. And if you look it very carefully, dear students, this equation and this one, as if like p1 is minus 1 by y, as if this is p1, okay, and as if this 2y is like q1, correct or not? Then what is the integrating factor? So here you get the integrating factor as e to the power minus 1 by y dy, correct? So this is equal to what, dear students? This is equal to e power minus integration dy by y, that is equal to e power minus log y, that is equal to e power log 1 by y, correct? Using the properties of logarithm, e power log 1 by y, that means 1 by y, correct or not? So what we get, dear students, in simple terms, that integrating factor is now 1 by y. Now as integrating factor is 1 by y, what is the solution to this differential equation? This formula we are going to use, x into integrating factor. So that means the solution to this differential equation here, from here I can write, okay, what it will be? X into the integrating factor 1 by y. X into 1 by y is equal to integration q1. What is q1? 2y. 2y into integrating factor. What is integrating factor? 1 by y. 1 by y dy. Clearly understood? Very simple, correct? So this implies, so if we do it here, this implies x by y is equal to 2 integration dy, correct? Y got cancelled. We can write since y is not equal to 0. So from here what we get, dear students? So this implies x by y is equal to 2y plus 1 integrating constant c, correct? So this implies x is equal to 2y square plus cy, and this is the solution to the given linear differential equation, this one. Okay. So with this note, let me conclude the session here, dear students. In the next session, we will solve few more problems on linear differential equations. Till that time happen, your task is to log into the online test platform at konarclasses.com and appear for DPP, that is daily practice problem, followed by PT, that is practice test, followed by UT, that is unit test, followed by MDT, that is module test, and finally mock test. In this way, if you prepare, your preparation will be rock solid. Thank you very much. Bye bye.